Disabled and mired vehicles will always be a large factor on the battlefield and during field training exercises. Today's recovery operator should be extremely proficient with towing, winching, and lifting disabled equipment so that it can be repaired and returned to the battlefield. The purpose of recovery is to rapidly remove disabled or mired equipment from the battlefield. If you are a member of a recovery team, you must ensure that you use the correct recovery techniques and equipment so the vehicle is safely recovered and all members of the team are not put in harm's way. The recovery acronym is used to systematically perform all recovery operations. Before you begin to recover a vehicle, you must understand the 8 steps of recovery. Reconnoiter the area, estimate the situation, calculate the ratio, obtain the resistance, verify the solution, erect the rigging, recheck the rigging, and you are ready to safely recover the vehicle. A recovery worksheet will be used to calculate if the available effort is capable of recovering the disabled vehicle. Before we explain the recovery worksheet and the 8 steps of recovery, there are some common terms you should understand, such as load resistance, tackle resistance, total load resistance, mechanical advantage, fall line and fall line force, deadline and deadline force, mire factor, and winch capacity. Load resistance is the estimated weight of the load. Tackle resistance is the resistance created by friction in a tackle system. Total load resistance is the total amount of resistance in a load. It's calculated by adding the load resistance and the tackle resistance. Mechanical advantage is a small amount of force applied over a long distance to move a heavy load a short distance. The fall line is the first line from the winch to the rigging. Fall line force is the amount of force on the return and support line. The dead line is the line, usually a chain that is used to anchor the tackle system. Deadline force is the amount of force on the lines that anchor the tackle system. Mire resistance is created when mud, snow, or sand becomes impacted around the wheels, tracks, axle, gear housing, or hull of the vehicle. There are 3 levels of mire resistance. Mire factor 1 is mired to the center of the hub or less. Mire 2 is mired between the hub and fender. And mire 3 is mired over the fender to the cab or turret level. Winch capacity is the maximum load your winch can support. Now that you are familiar with the common terms, let's plan our recovery. The first step in planning your recovery is reconnoiter the area. During this step of recovery, you should establish area security and then survey the entire area for the best approach, method of rigging, any natural anchorage, and an evacuation route. A good recon of the area will prevent possible disablement of the recovery vehicle. Step 2 is estimate the situation. We will use the recovery worksheet to calculate the required configuration for recovery. We must first determine the available effort, which is the winch capacity of our recovery vehicle. The winch capacity can be located in the recovery vehicle's -10 manual or on the data plate. The winch capacity of our Hemet wrecker is 60,000 pounds. Next, we must estimate the resistance of the load. Line 1 on the recovery worksheet. Before we estimate the resistance, let's ensure you understand the 5 types of resistance you might encounter during recovery. Mire resistance is created when mud, snow, or sand becomes impacted around the wheels, tracks, axle, gear housing, or hull of the vehicle. Load resistance is the gross vehicle weight plus the cargo weight multiplied by the mire factor. Overturned resistance is the weight of the vehicle that acts against the force exerted to bring it back on its wheels or tracks. To calculate overturned resistance, you add half the weight of the vehicle plus the cargo weight. Grade resistance occurs when a vehicle travels up a slope. Grade resistance is vehicle weight plus cargo weight. Water resistance occurs when submerged vehicles are pulled from water to land. Water resistance is calculated the same as if the vehicle is on land. Tackle resistance is friction created by a sheave rotating in its pin, the rope flexing around the sheave, or the rope scuffing in the groove of the sheave, causing a loss in energy as the rope passes around the sheave. Tackle resistance is calculated by multiplying 10% of the load resistance times the number of sheaves in the tackle. In our example, the vehicle weight is 45,000 pounds, plus a cargo weight of 0, multiplied by a mire factor of 3, so our load resistance equals 135,000 pounds. When calculating for a track vehicle, you must subtract the reduction factor from the load resistance before moving to the next step. When power is applied to the tracks of a mired vehicle, the movement of the tracks helps to break the suction of mud against the belly of the vehicle. Power applied to the tracks equals a 40% reduction of resistance. When a mired track vehicle is recovered in the opposite direction of its travel, the tracks pass through ruts made by the vehicle when going into the mire. Recovering it in the opposite direction of travel equals a 10% reduction of resistance. The third step of the recovery process is calculate the ratio. This means we need to compute an estimated mechanical advantage required for rigging, line 2 on the recovery worksheet. A mechanical advantage is a small amount of force applied over a long distance to move a great load a short distance. A mechanical advantage is needed whenever the load resistance is greater than the winch capacity. The mechanical advantage of any simple tackle system is equal to the number of winch lines supporting the load. In this example, you will notice a mechanical advantage of 2. To calculate the required mechanical advantage, divide the load resistance by the winch capacity. Our load resistance is 135,000 pounds, and our winch capacity is 60,000 pounds. So the required mechanical advantage is 3 because you must always round up to the next whole number. A mechanical advantage of 3 will require 2 blocks. The fourth step of recovery is obtain the resistance. During this phase, you must determine the tackle resistance and total load resistance, lines 3 and 4 on the recovery worksheet. Before we calculate tackle resistance, let's discuss blocks and tackles. Blocks and tackles are used to gain a mechanical advantage, align a load evenly, or change the direction of the pull. There are two types of blocks: conventional block and snatch block. A conventional block may have more than one sheath and the shell does not open. They are generally used with fiber rope or permanently installed on a steel cable system. A snatch block opens to allow a cable to enter without reeving. The side of the snatch block that opens is the weak point and must face the ground while in use. There are three types of block configurations: fixed block, running block, and floating block. A fixed block changes the direction of the pull. It does not provide a mechanical advantage except during self-recovery. A running block provides a mechanical advantage. Remember, the mechanical advantage is the amount of lines that support the load. In our example, we have a mechanical advantage of 2. A floating block aligns the pulling force with both sides of the load to pull evenly. There is no mechanical advantage. A tackle system is a combination of cables and blocks used to gain a mechanical advantage or to change the direction of a pull. They are classified as simple or compound. A simple tackle system is one cable with one or more blocks. A compound tackle system is 2 or more simple systems working together. Now that we understand block and tackles, we can calculate our tackle resistance and total load resistance. For each passage of rope through a block, there is a 10% loss of energy. So tackle resistance is calculated by 10% of the load resistance times the number of sheaves in the rigging. Our load resistance is 135,000 pounds, so 10% is 13,500. We have 2 sheaves in our rigging, so our tackle resistance equals 27,000 pounds. To calculate our total load resistance, we must add our load resistance plus our tackle resistance. Our load resistance is 135,000 pounds, and our tackle resistance is 27,000 pounds, so our total load resistance is 162,000 pounds. The 5th step is to verify the solution. In this step, we must compute the fall line force and dead line force. The fall line is the first line from the winch to the rigging. Fall line force is the amount of force on the return and support line. We calculate the fall line force by dividing the total load resistance by the mechanical advantage. Our total load resistance is 162,000 pounds, and our mechanical advantage is 3, so our fall line force equals 54,000 pounds. The winch capacity must be greater than the fall line force. If not, add 1 to the mechanical advantage and rework the math from the mechanical advantage down. At this point, nothing has been rigged, so there's no time lost due to incorrect rigging. Our winch capacity is 60,000 pounds, which is greater than our fall line force of 54,000 pounds. This configuration will work. Next, we must calculate the deadline force to determine the required strength capacity of the equipment we use as deadlines. Deadline force is the amount of force on the lines that anchor the tackle system. To calculate our deadline force, we must count the number of winch lines supporting the deadline and multiply by the fall line force. Now that all the calculations are done and we are aware of how we must rig our system, we can begin the 6th step of recovery, which is erect the rigging. Before we erect the rigging, let's recap on some of the rigging terms. The fall line is the winch line that runs from the source of effort to the first block in the tackle. A return line is a winch line rigged between the block or the winch line from the sheave of a block to the point where the end of the line is attached. A dead line is a line used to attach blocks or other equipment to the load or to the anchor. Now that we are aware of the required rigging, we can orient our crew and begin connecting to the load. During the erect the rigging step, we should orient our crew and instruct them how to assemble the tackle. Work as a team and observe all safety precautions. The 7th step of recovery is recheck the rigging. During this phase of recovery, you must ensure the tackle is rigged for safe operation. Remove any slack from the lines and move everyone to a safe area. The final step of the recovery process is you are ready. At this point, you can safely recover your disabled vehicle. All recovery operators should maintain a copy of the rigging card for vehicle recovery, GTA 09-14-002. It provides the 8 steps of recovery, safety precautions, and many more calculations that will be required during recovery operations. Remember, today's recovery operator plays a vital role on today's battlefield. It is your responsibility to safely recover disabled and mired equipment and return it to the fight as quickly as possible.